Today we're going to talk about 2015 AMC 10A Problem 14. The diagram below shows a circular face of a clock with radius 20 cm and a circular disc with radius 10 cm externally tangent to the clock face at 12 o'clock. The disc has an arrow painted on it, initially pointing in the upward vertical direction. Let the disc roll clockwise around the clock face. At what point on the clock face will the disc be tangent? When the arrow is next pointing in the upward vertical direction. So right now we're tempted to choose D, and this is why this question is a trick question. So basically what I did here at first that got me choosing D was that I calculated the circumference of the circular disc, which is 20 pi, and the circumference of the clock is 40 pi. So 20 pi over 40 pi is going to be 1/2. So for this disc to rotate 360 to come back to its original state, basically, I thought that this disc has to rotate 1/2 of the length to rotate its full circumference, right? So I just chose 6 because 6 o'clock here is 1/2 of the circumference of the clock. However, this is the wrong answer, and basically the key here is that you have to realize that we want to know, so at what point on the clock face will a disc be tangent when the arrow is next pointing upwards? So basically, maybe 2 o'clock is one of our options, right? So maybe at 2 o'clock, my disc was tangent like that, and my arrow is pointing upwards. So all we want to know is, when is the next time that, my tangent point changes, and my arrow is still facing upwards, my disc doesn't change. So that's a different question to when does my circular disc complete a full cycle, a full rotation 360 degrees. So basically, now we understand why 6 o'clock isn't exactly right. So it took me a long time to understand this. If you don't understand this, you can try to cut out these two shapes on your paper and, try to simulate this problem here. So just assuming you've cut out the paper or anything and you understand why we can't choose 6 as our answer, let's work out the actual answer. So the actual answer here is, so we find the center of the circle, and then, so how much does our arrow rotate? Well, the center of the circle doesn't ever change its position. It's still in the middle of the circle no matter how much degrees you rotate. So we can use that as reference. So I want to know, so let's say I have a circle here. I want to know how long does this path have to be in order for my arrow to face upwards again. So how long does this path have to be? So this path has to be 20 pi, or the circumference of the circular disc. So why is that? So let's say I rolled my circular disc on a 1D surface like that, on the 1D line, on the line, and then if I just kept rolling it, the distance from my original center to my final center would be this much. And that is actually just, the distance of my 2 tangent points here. So that actually shows how much we've rolled the circular disc. So we want that to be 20 pi. So how do we calculate this? So we know that the radius of our, large circle here is going to be 30 because this is 10 and that is 20. So it's going to be 30 pi. So actually we have 2 pi r over 360 times our fraction, so our angle here. So our angle here, which might not be a right angle, and any angle here. So times our angle, let's just call that x, because that's what we're trying to figure out. So that's equal to 20 pi. So if I just, divided both sides of the equation by 20, or actually no, let me divide both sides of the equation by pi. I have 2r over 360, so I can plug 30 in, so I have 60 pi so 60 over 360 times x is equal to 20. So I divide both sides by pi and I substitute r equals 60 in. So that just gives me 1 over 6x is 20, so x is 120. So that means, so this angle here is going to be 120, and that's just 1/3 of my whole 360 circle. So that just gives me, I have to go 1/3 the way of this clock here. So that's just 4 o'clock. 12 over 4 is going to be, 12 over 3 is going to be 4. So this is our answer. So the key point here is to realize that our distance, which we need to rotate, isn't exactly equal to the circumference. So the part here isn't exactly equal to the circumference, because as you can see here, our tangent point doesn't have to be the same position on the circle, but our arrow can still be pointing upwards despite the fact that the tangent point isn't the same. So this means that we can't expect a tangent point to be the same, so we can't calculate this as a circumference, 20 pi. So basically what we have to do here is we need a reference point that doesn't change despite no matter however the circle rotates, and that's the center, because the center is still, so here the center is still the middle of the circle, right? So it won't change. So that actually rotates 20 pi for the arrow to face upwards again. So basically we need a reference point, and we need to know why this this trick part of the question is wrong.